Ryan, it's so good to have you on today's podcast. I know you go back a very long time working with Golden Eagle Log and Timber Homes, so it's great to have you in the studio today.
Well, thanks for having me. I appreciate it. Yeah, I've been in this market since 2004, and I've probably been dealing with Tim or Mike for most of those years. So it's been a great relationship for us, as well as hopefully for you guys as well.
Yeah. How did you get into the engineered wood product industry?
So I started off. I went to the University of Illinois, and through high school and through college, I basically was building homes, and that's how I paid for my way through school. And so that being said, my advisor knew the equivalent of what I did in the Detroit market. He went through the same program at the U of I as I did, and we hooked up. We had some conversations, and honestly, I mean, I love the building industry, and it was just an opportunity to stay within something that I love doing. So, but also, it wasn't 10 degrees below zero, and it wasn't 90 degrees. Right. So,
your Trus Joist Weyerhaeuser, how does that relationship work? Is Weyerhaeuser the big parent company, and then Trus Joist is underneath them? Is that right?
Yeah. So Trus Joist originally is the one that developed the engineered wood technology. There were one seller and one engineer that kind of combined back in the 60s and developed the open web truss. They developed the Microllam technology and kind of started their own business. By the time that I got hired in 2000, Trus Joist was its own entity. And then in 2000, Weyerhaeuser came in and purchased the Weyerhaeuser brand and brought it under their umbrella.
That makes sense. I get a lot of builders and customers say, "Yeah, I want TJIs on my floor system." So that's the brand name really for the product called iJoist, right?
Yeah, correct. It's like tissue paper and Kleenex. Right. I mean, everyone says, "Hey, can you pass me the Kleenex?" That's the same equivalent on the engineered wood side. Right. We developed the technology. Everyone calls it. They call it TJI, TGI. I've heard all kinds of different, ways of calling it, but that's essentially what they're talking about is an iJoist.
And then Ryan, is the development of that what parallels the incorporation of open concept floor plans, really opening everything up?
Yeah, I mean, engineered lumber lets you go down that path and lets you look at it outside of just standard solid sawn lumber. I mean, that was one was to utilize the wood fiber in a better way, as well as gain some additional strength and capacity and the ability to move that to an open web concept, or not an open web concept, but an open format concept for the house to give you more space and get longer spans. And there's a lot of different things that we can do with the Trus Joist engineered wood products.
Yeah, it's a stronger product. It's more lightweight. I feel it's easier to install. You're not installing maybe two 2x12s at the same time. You're installing one iJoist. What are the longest spans that you guys can get in engineered wood? That's another advantage too, is that you can make them just about as long as you want, right?
Yeah. So in my market in particular, 48 foot's kind of our standard long length. We have capacity in some of our beam technologies to get in the low 60s.
Wow.
So that's a single length, and that just depends on the mill, on how big our building is. I mean, some of the process of some of the engineered wood that we put together, that is limited by the building length. They're just continuous feeds and continuous presses, or there's continuous lines. It's what's the building length that controls
sure.
that. But and then you get into trucking and things like that. Right. So, but 48 foot is a standard length, pretty much across the U.S.
Okay. So to back up a little bit, what in its basic sense, what is engineered wood products? I mean, we call them. We're going to probably hear it called EWP. So engineered wood products. What is it? How is it made? Let's start there, right? The very basic.
Okay. Yeah. So engineered wood products they're a byproduct of everything that you'll see today, except for TimberStrand, is we're taking wood fiber that you would traditionally see in solid sawn material. So we would take like a Doug fir or southern yellow pine, and we will break that down. Everything that we do today with engineered wood starts off as full logs. So we take the logs down and we basically break them down and put them back together. So in solid sawn lumber, if you were to look at a 2x10 or a 2x12 material, they'll have a 3/4 inch knot in the 2x material. That 3/4 inch knot is now 3/4 of an inch thick, and that's your weak point in that solid sawn material. So that's what controls its carrying capacity, its spanning capacity, and so forth. So like with Microllam in particular, that was our first technology. We figured out that we could take that same tree and we could peel that log. So Microllam is, if you have, I've got a picture, or I've got a sample of it here. It's basically a log that we've peeled. So we take a 20-inch diameter log and we will put that on a lathe. It's kind of cool. If you ever get the opportunity to see it, they'll put that and laser it and situate it within the thing. Then they spin that log. So now we spin that log and we get 1/8-inch veneers, and we take the same tree that would have been a 2x10 or a 2x12 and peel those into veneers, and then we build that up into a beam technology. So now if you were to look at this, you can see the 1/8-inch veneers on this material that are built up together. So now that 3/4 inch knot is only 1/8 of an inch thick. So we took one of the weaknesses out of it and randomized those defects to build something stronger than it is naturally. So that's kind of the concept of EWP. One on top of that is log utilization is another part of that. So if you were to look at our beam, so we have a 3-beam strategy: Microllam, Parallam, and TimberStrand. And part of the other concept with EWP is how do we maximize the use of the wood fiber that we're harvesting? And that being said, you know, a solid sawn timber like 2x mill will yield about 40% in finished goods of like 2x10s and stuff. Microllam is about 52%. Parallam is about 64%, and TimberStrand is about 76% of the log we can utilize for finished goods.
Wow. And why is that? Can you explain the difference? I mean, the difference between Microllam's PSL, LSL, TimberStrand. Explain the differences there.
Yeah, so when you see like a Microllam being manufactured, what we do is we spin that and we peel that log. Okay, we set those lasers to get to the most log utilization that we can get out of there. But to get Microllam, we need full sheets of veneer. So that log's got to be perfectly round. No log is perfectly round. So we lose some yield on the outside of that with partial sheets that aren't full sheets of veneer. And if you think of a tree will grow as tall as it can, as quick as it can when it's younger, and then it slowly adds that mass on. So the strongest wood fiber is those outer layers. Like if you were to look at an old growth tree from 100 years ago, you can see the tight grain on the wood fiber. Now, wood has become more of a cash crop, like you would have with corn or soybeans in the Midwest here. It's a cash crop, but rather than a 1-year harvest cycle, we're talking about a 40 to 50-year harvest cycle is how we manage that. So we're trying to maximize those use to build that material. So that being said, Microllam was the first one produced. Then we moved to Parallam was our next technology. So this is our secondary beam option. So the reason we get more yield from this is if you can see on the ends, they're not full sheets, they're partials. So we figured out that we could strand that partial sheets and use the strongest wood to produce this product here. And so that's where we started with this, we moved to this, and then our final product is TimberStrand. And TimberStrand this is the one product that we use that you traditionally would not see as solid material. Like you wouldn't see yellow poplar 2x10s. So we're using yellow poplar and aspen to produce this technology here. And it looks a lot like OSB, but the differences are on the size of the strands and the orientation of how the strands are put in there. And we actually will press this and inject this with steam to collapse the air cells, because the last thing we want to do is when this gets wet to swell up.
Sure.
So
Is that TimberStrand what I've seen at job sites on those big feature walls with all the glass in them?
yeah, so we use TimberStrand in a lot of different ways, but one of the major ones, and especially what you guys do on your homes, we will use TimberStrand for a majority of that. One, because it's straight, it's consistent, it's not going to warp or twist, especially when you start to get into these 18. I mean, we've done some 20 plus, high 20s, I think, with you guys, tall walls. And that's been a whole change in dynamics over the last 20 to 30 years. You know, a wall that was tall in an old house might have been 10 or 12 feet. Now they're in that 20 plus feet.
So for the average listener right now, what are some of the uses for each of the products, and what are some of the pros, advantages of them?
Okay. Yeah. So a lot of what we do is TimberStrand. We start with TimberStrand a lot of times because TimberStrand we use for our rim board. So that's at the end of our joist, we will place that, and then that tracks the load from the roof trusses down into the foundation, where we ultimately want to get the load from the roof all the way down into the footings of the home. We'll use this for all of our stud material for tall walls. So you'll see a lot of that. We also use TimberStrand for beams. So those could be dropped beams in the basement, flush beams in the floor to pick up loads within the house. And Microllam is kind of a similar facet with that. So Microllam we don't do in tall walls, but we'll use it for dropped beams, flush beams. There's a lot of different applications with Microllam, and Parallam kind of falls into that same realm of what Microllam does. We'll do Parallam as well in some of the tall walls. Sometimes we get to a point where Parallam is needed because of the strength of the product. In the building industry, you'll hear E value. E value is a bending value and how much something can deflect. This is a 155 where Parallam and Microllam are 2.0Es. So there's different values where this is stronger in bending, but this is stronger in crushing and shear capacity. So it's just, they all have their niche within the building industry. And we're a little bit different than most engineered wood manufacturers. Most engineered wood manufacturers have just one technology, where we have the 3-beam technology.
And some of these products can be used on the exterior as well, right? I know some of these, I think the PSL we use on exterior decks and open up that space underneath the decks and eliminate a lot of those posts that you see are now gone.
Yeah, so we have the capability with the Parallam to do a treated. So we have untreated and treated Parallam, and it is exactly what it does. It allows you, especially with some of the buildings that you guys work with, they've got beautiful views out the back with picture windows and things, where traditionally, like in a deck, you may have columns spaced every 8 feet on center or something like that. We can go 20, 24 foot on center with some of these columns, and it's a niche. It's for a specific, view. Like, I wouldn't use it just to use it, but for the right application, it works really, really well.
Right. And while it may cost a little bit more for this product, you're eliminating those posts and those columns and those footings. So really, the cost you're spending on it is probably made up in those other costs.
Right.
Some of the TimberStrand, I know in one project we're using on all the walls that have cabinetry on them. We want to make sure, and I think those walls are going to be 12 foot tall.
Yep.
We want to make sure those walls are super straight. So any wall in that home that has cabinetry on it, we're putting TimberStrand LSLs as the studs in that home.
Yeah. So on top of like Zach, you had mentioned the tall walls, we do it there, but we also do, we call it zone framing. So we're framing on walls that are very sensitive to being out of plumb and, have granite and solid surface tight that are butting up tight to it. It works really, really well. for the little additional cost of this over a 2x material, it's quite frankly a no-brainer.
Yeah.
I mean, the builder I worked with back in the day, that's what we used to do.
Okay.
And I would imagine everything goes up so much quicker at the job site because is it pre-cut?
Yeah, so we do lineal footage, but we also do pre-cuts.
Yeah.
And 92 and 5/8, 104 and 5/8, 116 and 5/8. So we have 8 foot, 9 foot, and 10 foot as pre-cuts.
And back to those tall walls, because that's what everyone loves, is they like the bigger glass openings. When you look at just the frame of that wall, there's a lot less material being used overall than if you had to frame it with conventional 2x6 material.
Right.
So
right.
we're getting much bigger sight lines. And I'd imagine the construction time would be a lot less as well.
Yeah, it is. It is. But it's I will tell you, it's a very important process in that. So obviously your team and some of my team helped with some of the design work on that. It's crucial that we're looking at that, because tall walls are very much like, I always say they're like a floor system up on end. If I have a joist that's spanning 10 feet and then I decide, you know what, I'm going to get rid of that steel beam or that wood beam in the basement, make it 20 feet. You don't leave the same 2x10 joist like we would have back in the day. You bump that up, or it goes to 14 or 16 or, TJIs or something of that sort. Same thing's true with wood. In a tall wall, if I go from a 10-foot wall to a 20-foot wall, I've got to address that. I've got to look at that and see, and especially when I start pulling out all these studs, because I've got 6 and 8 feet wide of glass going top to bottom. So it's an important process. It really got going back when I started. That's when they really started hitting on it in about 2000. We saw some situations that were not good because people didn't address them.
Yeah. So what are some of the concerns if it's not engineered correctly? What are some of the concerns with those tall walls?
Yeah. So if they're not done correctly, you're going to get excessive deflection in those studs. You're going to get, and this is what drove some of the tall wall stuff back in the day, is window manufacturers were having seals pop, panes pop. There was water infiltration down the wall, because what they figured out that the wall, the supporting like king studs along the sides of the windows weren't strong enough, and they were just deflecting too much. And because they were deflecting too much, those seals and things were failing. And early on, companies like Anderson and some of those, they were replacing those windows and weren't quite sure what was causing it. And then they started to figure it out. And now if you start to look in some of the window manufacturers' literature, they'll have deflection limits of how much a wall can deflect.
Sure. And the nice thing about engineered wood product is that it's consistent, so it can be, I feel, easily engineered. You guys offer, or there's a software out there that helps our design team engineer those products. Is that correct?
Yeah. So we've got a software called Forte Web, and it's something that we offer to our customers. It's available to people, architects, engineers, to run. And it started off as just engineered wood as a software, but now we've incorporated that into all of our products, TJI's, Microllam, Parallam, TimberStrand, but we've also incorporated that in there with glue lamps, steel beams, commodity lumber. One, because we wanted to basically give our architects and engineers that are leveraging our products the opportunity to have one source of software.
Taking like the deflection, the wind speeds, all that kind of stuff into calculations.
Yeah. So, and those all change depending on the market. So you have the ability to toggle that to your specific market and wind speeds. Obviously with you guys build throughout the US. So a lot of times when we figure out where you guys are building, then we're reaching out to local code officials to figure out, hey, what's our wind speed? What's our snow loading? Because snow loading in northern Wisconsin is different than Tennessee. Mm-hmm. So those are the types of things that we're looking at when we're doing design work.
And that's the same software that we can then test the floor system too, right? To make sure, do we need extra bearing? Do we need to pick up another beam to carry some weight? Yeah.
So the software does, our standard deflection criteria. So a standard in the industry is L over 480, and that's basically L is the length in inches, and then 480 is the denominator there. So if I've got a 20-foot span, that 20 feet I times by 12, that gives me 240 inches. So that basically says that that floor can deflect a half of an inch. The other thing our software looks at, that's an industry standard. That's kind of what everyone follows. We also have something called prorating. It's called TJI Prorating. We developed it probably 20 years ago or so. But that prorating is something Tim's group and Mike and those guys leverage when they're doing design work for your guys' houses, because it looks at deflection of what code looks at, but it also looks at, if I'm sitting on the couch and the kids or the dogs run by, it looks at the vibration and how the floor feels. So it's our secondary check. You guys utilize it very, very well. It's probably the most underutilized tool that we have when we're looking at floor systems, because it gives you a pretty good feeling of, okay, I can look at anything you guys have done in the past, and I can benchmark what that prorating was, and I can replicate that field floor on, if it's a 10-foot span, or maybe the plan changes and goes to a 20-foot span, I can replicate that floor system in a prorating from that. And we do that when we're working with you. I mean, if I see something that kind of pops up, those are the types of conversations that Tim and I are having, or Mike and I are having on plans that you guys are working on.
So what are some of the things that we do to help maybe tighten up that deflection or that vibration? Is it, moving to a higher series of I-joist? Is it taller? Does that I-joist get taller? How do you tackle that?
Yeah, so there's different avenues that affect that. So if I'm looking at a floor system, one thing that affects it is, what's my on-center spacing? 16 inches, pretty standard. Okay. The next thing is our OSB sheathing. What sheathing are we using? 3/4 inch, 7/8, inch and an eighth. Another thing that is a big influencer on that is the depth of the joist in the series of the joist. So if you look at a TJI, so this is a TJI right here. So a TJI has, we call it a flange. So the top is a flange, and the bottom is a flange, and then the middle is the web material. So the flanges is what prevents the floor from deflecting, where the web is getting the load from the top flange through this web material down to the foundation. That's kind of what an I-joist was built on. It's similar concept. Like if you look at a steel beam, that's where the similar concept looks like. If you look at steel, it's got a flange on the top, flange on the bottom, and a web. It's the same concept with an I. But that being said, our flanges have, like this one is our 1 3/4. This is our most narrow one, but we'll go up to 3.5 inches wide in our flange, and that just increases the amount of strength and the performance of the floor system.
Are they always an LVL flange like that, or applied?
For truss joists, it is. In the
Okay.
industry, you'll see like 2x3 material, like solid saw material there.
Okay.
We've decided that Microllam is the best bet for us. It's more consistent. We know what it's much more predictable.
And obviously the height can change. What are the most common, or what size, in height do you guys offer the I-joist in?
Yeah, so we do 9.5 through, we'll go up to 24 inches in depth, but in a standard market, 9.5 to 16 is about where we max out on a readily available type product. Sure.
This is so interesting to me because oftentimes people just generically think I-joist, TJIs. They don't think of the whole scale of good, better, best.
Yeah.
And you could think, well, I'm building a new home. Of course, I'm not going to get any deflection in my floor. But in reality, we, like at Golden Eagle, we take it to the next step to make sure that, hey, you're going to actually have the best floor system for you. So you're not going to have any of those problems. Whereas if you go to any sort of generic builder, they may not be necessarily looking at it from that approach.
Absolutely right with that. I mean, like I talked prorating and things like that, all those little extra steps, our product it's not the sexiest. It's not, it's not like what you see here that, when you walk into the house, someone doesn't say like, "Oh, wow, that is an amazing looking eye joist." That's just never said. I mean, they'll talk about your cabinets, your finished goods and things like that. But I would argue that it's really, really important.
Oh, for sure.
Because you can have all these pretty things and it can feel, it can just not be very desirable, the floor system.
Yeah, if it doesn't perform well, doesn't mean anything. It can look as good as anything, but yeah, if it's bouncy or whatever, it doesn't make a lot of sense. And I think coming back to like our complete packages that we offer with Golden Eagle, I mean, we're taking into account what kind of countertops, the fireplace, is there stonework there?
Yeah.
I'm just thinking of all these things that we know what's happening on with the home, and we're going to load the floor system accordingly for,
Right.
for those products.
Right, and you do, and that's one of the things. Tim and Mike and your design team collaborate with us a lot of times on just, hey, if someone's not asking you what's your finished goods, and you guys kind of control that whole process, so that helps. But if people aren't asking those questions, I mean, you can go down a bad path pretty quickly. I mean, it's like I always say, like, hey, if I grabbed a 1 inch or a 1 foot by 1 foot, like if I'm talking to a group of builders or designers or stuff, and I want to hold that out at my side and hold it out there as long as I can. I give one guy a piece of carpet. I give another guy a piece of like 1 inch slate or something. That's what we're talking about. That you would rather have carpet on you than you would slate. And if you have slate, we just need to address it.
With the glues and the resins that are being used in these materials, do they add any additional strength? Do they vary across different product lines?
No. So the glue that we're using in here is an inert glue. So it's a small percentage of it. It's not giving us, it's just bringing the parts and pieces. It's not giving us additional strength at all. It's a glue that's been used for hundreds of years. It's an inert glue. So once it cures, it's also, the wood will burn before the glue does. Some people ask us sometimes, hey, if the heat gets to a certain temperature, does the glue give way or this or that? And no, it doesn't. And it doesn't add additional strength. It just brings the parts and pieces together.
You mentioned before the I-joist, you can go 9 inch, 16 inch, all the way up to 20 inch. What's the advantage for a taller joist?
Primarily longer spans. I mean, so if you took a 9.5 or 11 7/8, you're probably going to want to max those spans out at 16 foot for 9.5, 18, 19 foot for 11 7/8. I mean, you can go further than that, but based off of the style of home that you guys do and the clientele that you have, those are some of the levels. But when you start to get into 16, 18, 20, I mean, now you're pushing into the mid 20 for spans. So back to Zach, your concept of open concepts and things changing over the years of, people wanting big spaces in the basement and so on and so forth. That's where some of that plays in.
You also mentioned the floor sheathing being a factor in the strength as well. How does that help in the strength?
Yeah, so what it does is OSB doesn't necessarily stop the floor from deflecting, so it doesn't make this stronger from a bending perspective, but what it adds additional mass to it. So you've got commodity OSB, you've got higher performance ones like Edge Gold is our higher performance one, has a little bit more higher resin and glue in there. It still meets the commodity realm. It's a little denser, and by being denser, and then we also had one, we don't carry it anymore, as Diamond, and it's a higher grade one that actually adds performance to it. So what it's doing is it's adding mass to the top of the flange, and that mass is what eliminates some of the vibration, and that's what helps your pro rating out. So if I go from like a 3/4 inch to a 7/8 inch deck, a 7/8 inch deck that floor will feel significantly better than a 3/4 inch.
Okay. What if you have a single story home and maybe it's on a full basement, you don't finish that lower level right away, and those I-joists are exposed? Is that, you mentioned the top flange being secure. What about having something like a surface on the bottom of those flanges or those I-joists? Is that going to help in performance as well?
It will help in performance. A lot of times when we do design and we know it's not a finished basement, we won't put that on there. But if I was to finish that basement and put drywall on the bottom side of that to finish that off, it ties everything together. So it gives you we call it a diaphragm on the top and a diaphragm on the bottom. That ties everything together and it creates kind of a sandwich there.
Sure. Makes sense.
Yeah.
We've done a full-length build series on homes from start to finish, and some of our viewers out there have seen that OSB was being used for the floor systems and roof sheathing as well. They've commented that they suggest we should have been using plywood. And I don't think that they realize that OSB has come such a long way. And kind of like a previous conversation we had, there's a varying degree of OSB out there. So will you touch on the comparison of OSB to plywood and really emphasize more on the best version of OSB and what that looks like?
Yeah. So OSB, so that was something when I started. I mean, there was plywood and there was OSB. Plywood is similar to a microlam in the sense that they peel that veneer and then they build that up into 4-ply or whatever the case may be of subfloor or wall sheathing and different things like that. So this OSB goes back to, they've come a long way. I mean, early on, yes, OSB, there were concerns with it swelling and different things like that. The industry has come a long way in regards to that. They've dialed that technology in, and it's very high performing. If you look at our TJI, like our web material, back in the day, it used to be plywood, and we've transitioned that about when maybe a little before I started to an OSB. And the reason for that is, if you look at plywood is veneered and then laid in the same direction, and it's laid up on top of one another. As you think of like loading, plywood has less shear strength. So shear strength is the ability for it to rip apart from one another. And because everything is lined up in the same plane, it's easy for that to rip. Where if, like with TimberStrand, this is where I was saying there's a difference between that technology, the way it's made up. The TimberStrand is stranded, and those strands are intertwined this way, so it's stronger. Same thing is true with OSB. It's a stronger shear strength, so it has more ability to transfer load and things of that sort. So it's come a long way. And then on top of that, when you talk about flooring and things, they've added additional adhesives to it to the point where like our Edge Gold has a 200-day no sand warranty when it's on the job site, because we want that to perform, and we have a track record that it does perform with no sanding.
So explain that to customers. 200-day no sand, meaning from the day it was applied, 200 days, you wouldn't have to sand that floor to even it out, right?
Correct. So a lot of times, like when you go to put a finished floor, whether that's hardwood or tile or something like that, the seams. So if I'm looking at this, so this would be our Edge Gold product. So this product right here, when you take two sheets and you butt them together, if there was excessive moisture there, you would get ridging located right here, and that ridging then needs to get sanded off. So the Edge Gold product carries a 200-day no sand warranty on something like that, to give you time to get the home under cover and under roof so that it's out of the elements.
Yeah, it's definitely, OSB is not the old, I still get people that call it wafer board.
Yeah.
I mean, OSB, what's the acronym for it?
Ornated strand board.
Right? Yeah, the strands are ornated in a certain direction to make it stronger, right? Yeah.
Yeah. Yeah, and that's what's with like TimberStrand, these are all aligned in the same direction for the most part, the strands. And then we do that to get the strength in this direction, where OSB is, I've got a mat that goes down this way, and then a mat that goes this way, and then a mat that goes this way. So my strength axis is in the flat.
Sure.
So that's kind of the difference between a TimberStrand and a OSB as well.
It's kind of an off the wall question. Are you guys harvesting your own logs and everything too?
Yeah, so we're a vertically integrated company. So we own 11 million acres in the U.S. And then we also manage about 13 or 14 million in Canada. So we harvest all of our own logs for our material. And we harvest at a rate of about 2% of what we own a year for all of our goods, for all of our softwood lumbers and our engineered wood products and our OSB products. So so we own the land, we own the manufacturing. We also have a little bit of distribution in certain markets, not in the Midwest, but primarily West Coast and some East Coast, in the South a little bit.
So where are a lot of the products being made?
So we have 6 engineered wood plants, and a lot of it is in like Alabama, Louisiana. We've got a mill in West Virginia. Our TimberStrand mill is in Kenora, Canada, which is just north of the Minnesota-Canada border. And then we've got some on the West Coast in the Pacific Northwest in Oregon.
Do the products ever change their wood species, or are you very consistent with the wood species that's being used?
Yeah, so that's a great question. Yeah, the wood species is relevant to the wood fiber that we have access to. So our West Coast mills, we're using Doug fir primarily. Where in the South, we're using southern yellow pine. So if you look at a map of our wood that we have resources, Pacific Northwest, we've got a big chunk there, and primarily in the Southeast. That's where our wood fiber is. And our goal is to try to, we want a wood basket close to the manufacturing mill that we're doing. So we don't want to harvest a log and then cart it halfway across the country to a manufacturing. So we set our mills up, and we call it in the wood basket. So in a surrounding area where we have access to the resources that we need to produce the product that we've got. So like Kenora, we harvest that, and that's the yellow poplar and aspen, and we plot that in the middle and then harvest around that to access that wood fiber. The wood side of the business is kind of cool. I'm not part of it, but I've been exposed to it with some of our mill tours and things that we've gone on out there, and the science behind that is incredible, like the replanting and stuff. I mean, if you look at what we harvest, we replant, I think last year they said 150 million seedlings we replanted. So the forest is not going anywhere. We value it. We need it for our continued growth and the products that we produce. And it has been one thing that Weyerhaeuser has done from the beginning. They've managed their resources. In 1900 is when the company was founded, and they've kind of been managing it. They were kind of leaders in that from the get-go.
Yeah, I feel like you guys, like I mentioned earlier, are the leaders in the industry. Everybody calls it by your name, TJI's.
Yeah.
And you guys, engineered wood products have certainly changed the game. In designs of the homes, spans are getting larger, spaces are getting larger, windows, tall walls are getting larger and more expansive, more glass, opening up that area. And that's all due to engineered wood products and you guys.
Yeah.
Sustainability is a big part of your messaging as well. Mm-hmm. And would you touch on that? There seems to be a bias out there. Perhaps this is an old bias, but there are some people out there that think that if you ever cut down a tree, that you're harming the environment and the planet. So will you please give us your perspective on how you see the correlation of sustainable forestry and also the use of these materials in homes?
Yeah, the industry in general is, everyone has rules now that the government was part of. If you roll the clock back to the, early 1900s or any of that, to me, that's what people are talking about. The way it's done today, it's like a cash crop, like I was saying before. We're harvesting 2% of what we own, and we're planting 150 million seedlings to circumvent the product that we've harvested, and we're not going and taking whole chunks of a mountain hill. they're sections. I mean, it's almost like in farm, like you've got your section of corn or this, you're taking a section and you're leaving additional trees and there's additional shrub and things like that. And that's all there for the wildlife so that they still have the ability to move from forest to forest and still have cover and things of that sort. So there's a lot of things that go into that. It's not my specialty, but I mean, the thought process of people just clearing forests and things like that just doesn't happen anymore.
You guys would be out of product real fast.
We'd be out of product real fast. I mean, you know, I was reading something one time that our scientists are looking 100 years down the road. They're already managing the forest for the next generations to come. Like, this isn't a fly by the seat type of thing. I mean, the science behind this is incredible. From the seedlings to where you plant to how you plant and how that all goes, it's incredible. And like I said, I was reading something that said, you know, 100 years down the road, they already kind of know what their game plan is from a big picture perspective, which is the right thing to do. I mean, obviously things like that may change, but we're planning for it.
I think using natural resources in home building just makes a lot of sense. Not only are there zero emissions in growing those trees, of course, and we're actually helping the planet when growing all of them and doing all the replanting, but additionally, you're sequestering all that carbon when you're actually using it. Now, take that in comparison to all these manufactured products that are out there. Can you imagine making a plastic siding, all the emissions that would go into that?
Yeah.
And all the unknown chemicals. That to me is so extreme compared to using wood products.
Yeah.
Will you touch on your warranty?
Yeah. So, I mean, our warranty basically is the life of the structure for this. Our treated lumber has a 30-year warranty, which is very high for any kind of exposed exterior treated process. You know, it's the one thing that I will say about Weyerhaeuser. They're amazing to deal with from that perspective. They stand behind their product like any other good company does. There's never been a situation where they've ever put me in that, you know, if something was wrong, we took care of the problem. You know, it doesn't happen very often, but when it does, it's reassuring to know that you've got a company that backs you that way.
And that's why we've enjoyed working with you guys throughout all these years as well. Yeah. Because not only do we use the manufacturer warranty, but then we've got the Golden Eagle seal behind that as well.
Yeah.
So,
yeah, you guys have been a great company for us.
Thanks so much, Ryan. Well, it's been great having you on today's podcast.
Super informative. I love this stuff. I dig into this stuff with my design background. So it was, and I learned a lot as well. So it was awesome.
Cool. Well, I appreciate the opportunity to tell our story. I mean, you know, a little bit of cameras and stuff. I was a little nervous here for the first time, but other than that, I mean, quite frankly, it's a good story. I mean, like when you look at where Trus Joist started and where it is today, I mean, it's a cool story.
Imagine a life where your home is a work of art, where nature and luxury embrace, with a custom Golden Eagle log and timber home. Our expert team is here to guide you every step of the way.